Welcome back to the FastAPI Backend series. A backend without a database is just a web server. Today, we connect our FastAPI application to PostgreSQL properly, not with hard-coded credentials, not with messy session handling, but with production-level structure. In this episode, we add secure environment variable configuration. We configure the SQLAlchemy engine. We implement a proper database session dependency, and then we test the database connection, and then set up VS Code debugging for real backend development. This is where the API stop being infrastructure and start becoming a real backend. Now let's jump to our Northwind Light FastAPI application in VS Code. Before connecting to PostgreSQL, we need to handle configuration properly. Database credentials should never live inside source code. They belong in environment variables. To start, we'll create a new file called .env in the project root. This file stores environment-specific configurations. So we'll create the file using the touch command under the root folder and hit enter. And if we move over to our file explorer here, we'll see the new file that we created. We'll open the file and then we'll type in our first environment variable. The name of this variable is called database underscore URL, which is pretty much holding our connection string of our database. So where do we get this connection string? Well, if you followed my how to build a production-ready Postgres database in the cloud series, you already created a managed Postgres instance. You can briefly find your connection string if you, for example, go to your dashboard of your provider. I'm currently using Neon, and my series actually use Neon as the provider. I can easily get the connection string by click on the connect button here, and then I can easily just copy this connection string here and place it in my code, replace this with my code, and then use that as my database URL environment variable. Cloud providers like Neon, Supabase, AWS, Azure, or any managed Postgres service generate this connection string for you. And also very important, make sure you never commit this file. So if we go to our git ignore file, as you can see, if you recall from our previous episode, we added the .env file name in here to make sure that we must never push this into GitHub. So this ensures us that this will never be pushed to GitHub. If credentials are ever committed publicly, they should be considered compromised and rotated immediately. So that's why we're doing this. So now we have our environment variable set, database URL, which holds our connection string. Then we ignore this so it never gets pushed or committed into our repo environment. And why environment variables matter. Separating configuration from code allows the same code base to run in development, staging, and production without any modification. So development, you'll have your local database. Staging, you'll have a test database. And production, you'll have a live database. Same code, but different configuration for each. And what happens in production, the environment variables are injected by the hosting provider, not stored in a file. So configuration belongs to the environment, not the repository. Next, we create the database configuration file. But before we begin, make sure our virtual environment is still active. You know it is if the front of your terminal command prompt shows the VNV between the two parentheses, as you see here. To create the file, we can basically use the touch command and make sure it's inside of the app folder. And the name of the file, we'll call it db.py, and then hit enter. Now that the file is created, we can go here and open the file. As you can see, it's empty now, waiting for code. This file is responsible for database infrastructure configuration. It centralizes the database connection setup, the SQLAlchemy engine, the session creation, and the session lifecycle management. In short, that file is the bridge between your FastAPI application and the Postgres database. Now let's check out the code in the file. As you can see, we have several imports, including import OS. Import OS is Python's built-in operating system module, which allows your Python program to interact with the operating system. Before anything else, we load environment variables from the .env file. This ensures sensitive configuration, like database credentials, stays outside our source code. Then, we read the database connection string from the environment. This keeps our application flexible. We can change environments without changing the code. The application doesn't care where the database lives, it just reads configuration. Then we create the SQLAlchemy engine. The engine is the core interface between SQLAlchemy and Postgres database. Think of the engine as the infrastructure layer that manages connections efficiently. Next, we create a configured session class. Session local is not a session, it's a session factory. Each time we call session local, we create a new database session. That session represents one conversation with the database. Auto commit equal false means we can control when commits happen. Auto flush equals false means we can prevent automatic writes. Bind equal engine means we can connect sessions to our engine. We explicitly control transactions. Nothing happens automatically. Finally, we define the getDB dependency function. This function is a FastAPI dependency. A request comes in, getDB runs, a new session is created, that session is injected into the root. After the request finishes, the session closes. The yield pauses the function and gives the sessions to the root handler. When the request finishes, the code after the yield is run and closes the session. This is critical. It's critical because it prevents connection leaks, keeps the app scalable, and ensures predictable lifecycle. Every request gets its own clean database session, no shared state, no leaks. Why this structure matters? Without this pattern, session might never close. Connections could hang, memory leaks happen, production system crash under load. With this pattern, we have clean request lifecycle, safe scaling, and predictable behavior. FastAPI automatically injects a database session into the root. The engine manages connections, the session manages conversations, and the dependency manages lifecycle. At this point, we've configured the engine and session lifecycle, but we haven't actually verified the connection. Before building real endpoints, we'll validate the infrastructure. So let's go to our main py file and add another endpoint in there to help us verify the connection. As you can see, we still have the root endpoint we created in episode 2. Let's add more code to this file. So what did we change in the code? We added more imports, such as depends, text, session, and getDB. The depends import allows us to declare dependencies in our root functions. The text import allows us to use the text function to execute the raw SQL string. SQLAlchemy insists that raw SQL strings must be wrapped with the text function, otherwise expect to get an SQLAlchemy error. The session import means import the session component from SQLAlchemy's ORM module so we can use it to interact with a database in the Python code. Then we created an endpoint called health, and this endpoint doesn't return any business data. It simply verifies that the API and the database can communicate. To break it down, depends getDB injects a database session, and select one is basically a lightweight test query that we use to execute so we can return something. And that's pretty much what this endpoint does. And if it runs successfully, then the connection works. Now let's run the application to test this. Let's go to terminal. Let's clear the terminal. Clear terminal. And then we'll enter our unicorn command to run the application. So we'll enter unicorn app.main and then hit enter. After running the command, as you can see, the application is running on our local host. Now, if we go to a browser to test this, and we go to the local host, port 8000, you can see our first root level endpoint is running fine. Now, if we want to check our health endpoint, the one that we just created, we can use Swagger by going to docs. And then here's our second endpoint, health. And then if we play around with it and see if it gives us what we're looking for, we can try it out by clicking on the try it out button and then hit execute. And we can see the response here, status healthy, a 200 code status healthy, which is basically what we told the endpoint to do. So this basically tells us that the connection is working between the application and the database. Now that we confirm that the API and the database are now connected, but what actually happens during that request? Let's inspect it under a debugger. So let's configure a debugger to test this. We'll go to VS Code and click on the Run and Debug tab here, and then click on the Run and Debug button. Then we'll go here and select Add Configuration. Then we'll select Python Debugger and select a debug configuration. This creates a launch.json file for us, and we just need to configure this to work for our application. So let's remove all this code here and place the code that we need for our configuration. And basically we have configurations, the name and a type and the module and the apps as the argument and the port and so on. We'll save this. Now we're not just running the server, we're running it under a debugger. Let's set some breakpoints. So let's go to our File Explorer and click on our dbpy file, and we'll set a breakpoint somewhere in here inside of our getDB function. We'll put a breakpoint here. Then let's set another breakpoint. Let's jump to our main, set a breakpoint inside our health endpoint. Let's see, about right here. And now we'll run the debugger. You can see it's running, and it's letting us know that it's running on the local host and port 8000. So if we were to jump back to the browser, then we can activate those breakpoints. If we go back to our doc, Swagger docs, and then try our health endpoint, click on execute. As you can see, our UI is still loading because it's hitting that breakpoint. If we go back to the code, it's on this breakpoint, the one that we set on getDB. Notice the session is created before the root runs. That's what this means here. So if we were to step forward, you can see it's going, we're hitting our breakpoint and it's going through the code. And then it jumps to our other endpoint, which is the health. Now the database query execute. Then when it hits the finally block, after the response is returned, the session will close. This is the life cycle of a database session in FastAPI. In episode 2, we built the foundation of our FastAPI project, a clean repository and isolated Python environment. In episode 3, we brought that foundation to life by connecting it to a real database. To recap of what we built, so we have a secure configuration. We created a .env file which keeps credentials safe, never in source code. Then we set up the engine in a file called db.py, which created a database engine powering all connections. And then we set our session dependency in a function called getDB, which ensures that every request has a refresh session properly closed afterward. Then we validated our endpoint by creating an endpoint called health, which confirms that the API and the database are talking. And finally, we set up a debugging workflow in which we included breakpoints to show exactly how requests and database sessions flow. Now that everything is working locally, I'll push this code to GitHub. Once uploaded, I'll include the repository link in the description so you can clone it and follow along. In the next episode, we'll expose our first real data endpoint using a Postgres database view. This is where the backend stops being theory and starts serving actual data. Don't forget to like this video and subscribe to the channel so you won't miss the next episode. I'll see you there.